I don't care what operating system you run on your machine, this is the environment that we're going to run in. You don't need a virtual machine, except if you're a Mac or a Windows user. Of course, we're not all the same. There we go. Yeah, fine, whatever. Okay, and so you can go through and do that. And we have a whole stack of base images that you can use, like MySQL, WordPress, PHP, and so on, that mean that you can do this kind of experimentation pretty much anytime you want and throw it away. So for me, this was like step number one. I can start from somewhere where I want to go, where I am, whether this is the first client's machine or the second. I set up base images to do that, and then see what happens if I change to a new version of PHP. Okay. All right, so we should really talk about what a Docker image is. The fundamental thing is that Docker images are based on a Union file systems thing. And so we have a Docker file that defines how Docker will build these layers into the image that you use. And then they get unioned up, and when you go Docker run PHP, for example, it will run as though that file system is a normal file system, and it'll layer another union on top, and any changes you do in that container will be in your read-write layer, and then you can do as I just did then, and kill stuff or fix stuff. And if that's a useful image, you can then commit that image, commit the container into an image and continue the process. And what that means as an end result is that if you have 30 or 40 microservices, you would typically create a base image that has all the prerequisites that are common for all the base image, microservices, and then create images on top of that. And so you've got your base, which you ship out once, and each of your microservices would be a thin little layer, perhaps an exe, a few data files, that sort of thing, on top of that, and that's it. So updates generally, unless you're updating for security, are very quick. And as you can see, starting them, because all you're doing is starting the process, is also relatively quick compared to starting a virtual machine, or even worse, building a virtual machine. Down the tutorial yesterday, I went through a stack of commands, but let's see what I have. I have a whole pile of Docker images here that I can run. I can see what happened to, let's say, this image. So Docker history will tell me all of the commands that went into building this image, and I can inspect it, do things like that. All right. Changing base images. This is one of those fun things. Somebody was asking me just a moment ago, what happens if you've got a system on one version of WordPress or whatever, and you'd like to see what happens when you upgrade it? And you can pretty much do that sort of thing in what amounts to one operation. So I have here, for example, and I'm not using WordPress as an example because there's no base images for multiple versions, it's just the latest release. So if you're maintaining that, you'd be maintaining your own base images. But Golang, for example, we have images for Golang 1.5 and 1.6. So I have a make command that will go off and build. In this case with 1.5, that's what I was developing on. But if I want to change the version of Golang that I'm building with, because they did fix quite a lot of fun things, that was it. I'm sorry, I did that way too fast. All I did was change the version number on the Docker tag for the image, and off it goes and builds again. And you can see rebuilding my image in this case is incredibly fast because I had already previously downloaded all those images. So the slow part is downloading the images into your local Docker machine. And then each of these steps are what goes into building what effectively is my production image for, oh no, this is the build image. So basically all this is doing is copying the source that I have and then running a series of scripts that build it into a binary. And then what I normally do in production, to get a production image, is to take the output of this and make another image based on Alpine or something small and simple, and that's then what I ship out. And if you go and look at the difference in, oh, thanks a lot. If you look at the difference in sizes, the Debian base image, for example, is 120 odd meg, whereas the Alpine image is just under 5. And of course has an awful lot less baggage. Whether it's more secure or not, you should do your own analysis. Okay, so that's effectively all that would be required if you were to change anything. Your build process is hopefully the same, unless of course you're doing something complicated. Now when I was building the demo for this, the chat app, I thought it'd be really cute to do WebSockets, and then I found out that the Debian version doesn't have sockets compiled in. And so I went off and made myself a Docker file that gets the PHP source and builds it and so on. Nicely enough, it looks like the build process between 1.5 and 1.7 isn't massively different. So once I had everything working, I went and did the same thing. With PHP 7. So what I've created there is I've built 2 base images that I'm going to use to run my application on top of. And so I have a third Docker file, which is what I actually used. And as you can see, most of this is commented out because I moved stuff around. So there's our actual Docker file. I'm doing from my PHP 5 sockets image, a little bit of housekeeping. I'm adding Git and Vim just in case I want to go in there and muck around. I'm installing Composer, using Composer to install some stuff, and then starting PHP, and that's it. And then once I've got that, and I'm happy with it, I was very happy to find out that just changing to PHP 7 also still just worked. So for me, PHP 7 was beautiful. Okay. Now, where am I? So that was one of those it's a little tiny thing, but for me, those are the sorts of reasons why I find Docker incredibly useful. All right, we talked about what a Docker image is. The next thing is, having built, as in created a set of Docker files, you can start sharing these images. And there are 2 ways generally to do this. One is to use Docker Hub, a thing that my company provides, to build the images for you. So what you're doing is you're linking your Docker Hub account to your GitHub account or to your Bitbucket account. And any time that those 2 trigger a webhook to say you've updated your source, our Hub server will rebuild those images. And the nice thing with that is that it means anybody using your images instantly gets to see. Woohoo! Excellent. Thank you. What's wrong with doing that? All right, so we have an image, for example, and this one's automatically built by the hub, and you can see that it lists the source repository, and you can go off and audit what the heck this image is. So you have some level of trust that what you're getting is what the author intended it. And we have a number of extra bits and pieces called Notary that sign these images and verify that what you've downloaded is actually the same thing as what we're intending to provide. So man-in-the-middle attacks get a little bit mitigated. Stupid cross-site scripting, apparently, you know. What? All right, and the other way is that you can create a repository here that's not automated and do a Docker push and just push the image to the hub. And that means you can use your own CI system to build images and distribute them. And you can also sign them with Notary and all sorts of other useful bits. And we can do something I haven't done in a long time. You can search through the command line. Okay. And then the last part of the Docker engine itself is obviously running these commands and looking at the time. Okay, so I mean the most important being Docker PS will tell you what's running, and I can then go Docker logs, Redis, and that'll show me that there's stuff running. I thought there was more going on here than that, but okay. And so that lets you see the log file that is being streamed to the standard out and standard error. What else do we care about? Okay, and the last really useful command is that I can go and start a new process inside the container. And there we go. From the container, all we see is the commands that we've started inside the container, and I can go around, muck around with my Redis, do something useful. Whereas if I go from outside the container, I can also see those processes outside. Because as far as the host operating system is concerned, this is just a process, and we can do with it what we will. So I can kill this process, which will automatically kill the container. And that also means that if you have monitoring systems that currently monitor your processes, you don't have to throw that away just because you're moving to containers. You can continue to monitor them exactly the same way. There are obviously a few extra steps if you're watching files, because the file systems are hidden away somewhere in the Docker, in Varlib Docker, but they're still there. It's not as though this were a VM. Your host has to be trusted. Then again, with a VM, your host still needs to be trusted as well. Okay, how are we doing? All right. Other fun things is, as I hope I mentioned before, when you start a container, what's actually happening is it's being given a non-public network. And you can go and give it either, you can customize that to some degree. So by default, we put these things in their own networks or in a bridge network, but you can also start a container on the host network. So if, like some of us, you're running a Pixie server, and TFTP and so on need a bit more than just TCP and UDP, then you can run that and give it access and just say, put this on the host network. Or you can put it on its own network. And so you can start sharing networks between containers so that your Redis and your web server talk to each other without any extra overheads. And if you want to, for example, have a web server that is accessible from the outside world, you can run it, now this is going to fail, by mapping port 80. And this should fail dismally because I'm already running a web app that you guys are killing. There we go, port allocated. So instead, let's see if I got this the right way around. Yes, I did. There we go. So you can run as many web servers as you like. They don't know about each other. The only constraints that you have are effectively that you can only have one process listening on the host at one time. Now what this means is that you can scale really simply by having a cluster or a swarm of these things, which kind of is an opportunity to mention we also have a product called Docker Swarm, which aggregates a whole pile of Docker daemons and then provides a single Docker API. So the same Docker run commands can work on 20, 30, or however many computers you have. And so if I had this chatter and it was starting to have some performance problems, I could just start up several more in my swarm, make sure that it updates my DNSA records so that we can round robin them, or whatever other method I want, and then suddenly have 10 or 30 machines serving my cross-site scripting attack. Not that there's anything wrong with that. Is there? Okay. What else did I? Oh. All right. The other thing is, performance-wise, because Docker containers run using a Union file system, if you've got something like a database, you don't really want that. You want to give it real access to the hardware. And so you can start creating volumes that are non-UnionFS. They basically just give you a directory in your local file system, and you hand that off to your database, to your Redis or whatever, and go. That also gives you the ability to do the same sort of thing in a development environment, where you can set up your Nginx, for example, to by default use the HTML from its container. But if you set a volume from your local host to where Nginx is trying to pick that HTML up, you can go and edit that stuff on your local machine, and Nginx in the container will happily serve it. And then we have other little joys. You can pass environment variables in. That's pretty much the easiest way to pass passwords in. Yes, and you can go off and link containers together. That's kind of a quick rundown on what the Docker engine does. The next step really is to go and show, don't worry about what's going on. Yes. I'm going to skip that. Okay, DockerCompose. Now DockerCompose is pretty much the next step. When you're running a web server of some sort, you're not normally just running one process. You're wanting to have your PHP server talking to some kind of database. In my case, I'm talking to Redis. And then you want to have a web server, because surely writing a web server in asynchronous PHP is a weird idea, or somebody implied. And so what I did for that app that you guys are mucking with is define my service as being an Nginx container with port 80 mapped, a Redis server just running by default with no password, totally open. If you can hack that, brilliant, because I'd like to know. Because the thing is, it's not exposed on the internet. All of these three services, the Nginx, the Redis, and the PHP socket server, all are sitting on their own local network, and then the port mapping is what gives us access to those things from the outside world. It's not to say that there isn't a lovely bug in my code. And so here I am, having defined all the relationships between my containers, and all I need to do is go DockerCompose up. I have no idea what this will do, because I thought we were already running this. I think we've just reconnected, but is anybody out there? Or did you have to refresh? Excellent. So it looks to me like DockerCompose killed the previously running session and started up a new stack of containers. And I'm about to kill you all. Heckle! Are we there yet?
I'm not sure killing is allowed in the code of conduct, Sven.
Really? I'm not allowed to kill processes.
Well, you might need to do it gently.
Gently. Control C is not gently. I am sorry. That's unfortunate. Does that mean I get kicked out? Okay, so I'm now just going to go and switch versions of PHP just for the fun of it. And because I can never remember command lines, I'm going to go and use the help. So I'm going to force this thing to rebuild just to make sure. Yeah, so we just rebuilt that container with a new version of PHP. And as you can see, it didn't take particularly long. There we go. All right, so to me, those are the powerful things about Docker. I just changed everything underneath my application, and moments later I'm running it. I didn't have to wait for my operating system. You can love Vagrant all you like. I don't mind. I failed to find Vagrant my fun place. Your mileage may vary. Okay. Other than that, I'm doing this all on a Linux box. If you're on a Mac or on a Windows box, right now we have this thing called Docker Toolbox, which installs a native Docker client and creates a virtual machine, gives you DockerCompose, and then allows you to run commands as though you had a Docker for real. Oh, well, right. Stop distracting me. And seriously, one of the easiest things, or one of the hardest hurdles you have, is just installing it and trying it out. That's pretty much it. The biggest thing is, do you guys have any questions? Excellent. One question, then I go.
Hi. You mentioned different containers running the Nginx process, for instance, and the processes inside the containers don't know about the other processes. How does that work with CPUs, for instance, on the machine? So in an Nginx configuration, we typically define the number of worker processes, so one per CPU, per available CPU. If I have a 16-core server with already 16 worker processes of Nginx running, does it make sense then to create new containers with Nginx instances, or does it not?
If you're optimizing for CPU usage, then you probably wouldn't. You'd probably set up a new box and set up the other containers on a new box. But is Nginx CPU down most of the time?
At least that's what they say, what they recommend in their documentation. So they say.
But is that because they make that documentation based on the idea that you're getting so many requests that your CPU is maxed out just doing Nginx, which I'm guessing is not the case for everybody. It's just specific to unifying logic. So I don't know in the sense that it will depend entirely on the specifics of your requirement.
Mm-hmm. But
in my case, my web server is released in my home. But yeah.
right, but the idea in general is to create new containers with new web server instances because of high load, so that higher load can be processed.
So creating containers is not something you're going to be doing for no reason.
Right.
And just so if I have a scalability problem because of my web server, I'm not going to start a new container on that same computer. I'm going to have a small notebook, and it's going to know that I already have 16 Nginxes on my server using up all my CPU, and therefore go off and create the next one on the next server. You know, so it's not a way of saying let's replace 6 virtual machines with 6 containers, and that will allow me to scale up all the capabilities of my CPU.
More or less. Yeah. Actually, it's about when we talk about scalability, and we have well-sized environments, and we have a server dedicated for web server, and we want to do horizontal scaling. So the question is then more or less, new containers on the same machine doesn't make sense if the server is already under load. Therefore, launch new instances.
That's right. So it's not like Docker will magically allow you to ignore all the other
Right.
processes.
Okay, thank you.
Sorry, this is more just a comment on that question. So obviously, to do with tuning, you're then tuning to a Docker container how you'd want that to be as a segment of your deployment to scale, right? So then you're not relying on the physical hardware for the tuning. Is that the approach that you'd be taking?
So Docker Swarm has a scheduler that will allow you to decide where to place the container. So if you need a new NGS container and that service full, you place it somewhere else. So your tooling, yes, on that, it is able to ignore that fact that it's taken care of by another tool in the tool. To me, it's like you're not moving, you're not ignoring something, you're moving to another responsibility.
Hi. Could you talk for a second about some challenges, because nothing comes for free, right? What are the main challenges when working with Docker in production?
Gosh. Challenges are things like this. I find the biggest challenge seems to be that people go, this is a new tool, and it must solve all of the problems so I don't have to think about them anymore. So people talk about Docker not being a solution to the security problem, for example, because you can't safely download random software off the internet and it stops your machine from dying. So those are the sorts of philosophical challenges where we provide this tool and people then go, well, it does an awful lot more than it does. Oh no, it doesn't do any of that, so therefore it's bad. The reason I joined the company was because it didn't have enough downsides for me to, I just was astounded by the fact that I could take a horrible legacy app, just whack it in a container, and then slowly start splitting bits out. People think about Docker and go, I have to redesign my system with microservices. But you don't. You just keep working the way you do, just whack it in a container and then start squeezing bits out. So most of the challenges are because we haven't been doing this for that long. So we don't know what the best group is. We just know that this one works nicer than that one. And we're going to try a few more. Best practices seems to be an issue. Which is why we walk around encouraging people to try it. Because then they'll learn something. Sorry, I don't have very many.
Okay, thank you. One last question. I can see.
Thank you.
I can see huge benefits. As a dev, you can try different versions of PHP real quickly, all that sort of stuff. What would you see the main benefits are at a production level of using Docker in production?
It's the same as virtual machines, only not virtualizing your OS seems to be the biggest selling point at the moment. All of the big corporates are kind of going, we need to reduce our hardware by about 30%. And for me, it's 30 times. It is some ridiculously large number because you are just running a process. And obviously, most of the big corporates trust the processes that they're running. So you're not
Any more questions?
I'm not sure if this requires like a longer answer that I might have to talk to you about afterwards, but say you're not running one giant application across many servers, say you're running like lots of smaller applications on one server, and you're looking at this as a way of handling like obscure library requirements. Would you have to put a reverse proxy in front of it to handle different domain names? Or how would you handle that? I mean, obviously I've seen them running on different ports, but that's not going to solve, you know, different domains.
Yes, nothing's changed. You still need to have a proxy. It's not like you can magically create something from nothing. Sorry.
Cool. It's just funny watching when you've got that little chat up there and everyone all of a sudden becomes a JavaScript developer. My phone's going crazy. Sven, thank you very much, mate. Appreciate it.
No worries.